So question 3 says solve the system equations if the system has no solution. Again, say it's inconsistent. So as we mentioned, consistent and independent means we're going to have one solution. So we're looking for an ordered pair. So we're going to be looking for an x value and a y value. So x is going to equal something and y is going to equal something. Consistent and dependent basically means the two lines are coincident. There's infinitely many solutions, and the solution would be the equation of the line. And then inconsistent means the two lines are parallel. And since the two lines are parallel, they do not touch, and therefore there's no solution. So to solve this system of equations, we have this 1/2 x plus 1/5 y is equal to 3. And we have this 1/4 x minus 2/5 y is equal to -1. So these two equations have fractions. So what I want to do is give it fractions. And notice that a 2 and a 5, the least common denominator would be, you'd have 2, 4, 6, 8, 10. And 5, you'd have like 5, 10. So notice how 10 is a common multiple or a common denominator. So if I multiply by a 5 and a 2, in other words, if I multiply by a 10, that's going to get rid of both fractions at the same time. So to get rid of fractions, I'm going to multiply each side of this equation by 10. Doing so, remember, we actually do the division first. The 2 goes into 10, 5. 5 times 1x is just going to be 5x. And then we're moving to the 5. 5 goes into 10 twice. 2 times 1y would be 2y. And then 10 times 3 would be 30. So this is the new equation. And then if you look at the 4 and the 5, the least common denominator between a 4 and a 5, what I'd be seeing like 4, 8, 12, 16, 20. 5 would be 5, 10, 15, 20. So notice that a 4 and a 5 would have a 20 in common. Remember, we can also find a common multiple by using the prime factorization technique, but we're not going to go there at this time. So a 4 and a 5, what I'm picking up on is if you multiply by 20, it can knock out both fractions at the same time. So I don't have to multiply by 4 and then come back and multiply by 5. I can just multiply by 20. So notice that when I do that, 4 does go to 20 5 times, and 5 times 1x is 5x. 5 does go to 20 4 times. 4 times -2y would be a -8y. And then 20 times a -1 would be a -20. So these are the same equations without the fractions. So these are equivalent. So notice that the 5x and the 5x are the same, but they're not opposite in sign. So if I want to use the addition method, I can add these together as long as the coefficients are the same and opposite. They're not. So what I can do with this set of systems is I can multiply this first equation by -1, or I can multiply the second equation by -1. It really didn't matter. By doing so, this is now going to turn into a -5x minus 2y equals -30. And then we have 5x minus 8y is equal to -20. So we keep the system together. So when I add these together now, the addition method, notice that the -5x and 5x will zero out. That leaves me a -10y is equal to a -50. So if we divide both sides by -10, we get y equals 5. So -50 divided by -10 does give me a +5. So now that we found what y is, we can now substitute in to find x. So this 5 is going to get substituted. And again, I can use any equation up here. The one I like is this 5x plus, because there's no negativity in that one. So this 5x plus this 2y is equal to 30 is the one I'm going to choose. And I'm going to substitute in for y. Since y is equal to 5, this allows me to solve for x. So 5x plus 2 times 5 is going to equal 30. Well, 2 times 5 is 10, so 5x plus 10 is equal to 30. And then if you subtract 10 on both sides, 5x is going to equal 20. Divide both sides by 5, x equals then 4. So the solution set would be 4, 5. So notice how, again, it's going to be consistent and independent. So the ordered pair is going to be this 4, 5. So it looks like we don't have to graph this one. So we just have our solution set there. So essentially have two strategies, the addition method and the substitution method. You'll see probably the addition method is the more commonly one used in our math.